Part A then wants the value of the expression x cubed log x squared plus 2 when x equals root 2 over 4, and again when x is 3 root 2 over 4. So essentially substitute into the given equation and calculate the y value. And notice that you want to give your answer correct to 4 decimal places. Part B then asks you to work out the area using the trapezium rule. So the area is going to be a half of the interval. Well, the first interval goes from 0 up to root 2 over 4, so the interval is root 2 over 4. And then we're into the first plus the last plus twice the others. So 0 is the first, 3.9210 is the last, and then we want twice everything else. So 2 lots of 0.0333 plus 0.3240 plus 1.3596. And again, if all that goes in your calculator, the answer correct at 2 decimal places, which is what the question asks for, comes out to be 1.30. Part C then gives us a substitution, u equals x squared plus 2, and asks us to get this integral in terms of u. So again, the first thing we're going to do is find du dx. Du dx is going to be 2x. So rearrange to get the dx on its own, and dx is equal to du over 2x. So when we come back to our integral here, what we're going to do is, I've noticed on the bottom here I've got an x term, and from here I know I can rewrite this to say x squared equals u minus 2. So I'm going to write this term here as x times x squared log u, and then my dx becomes a du over 2x. Now this x and this x are going to cancel out. My x squared here is going to become a u minus 2. I've got a log u and then a du over 2, so I'm going to write that as a half u minus 2 log u, and again I can take the half outside and I'm left with u minus 2 log u. I need to look at limits, so if I look at my limits, when x equals 0, u is equal to 0 squared plus 2, and when x is equal to root 2, u is equal to root 2 squared plus 2, which is 4, so my new limits are 2 and 4. And you need all this here written down. The question says show that. So then make sure you put everything down. And then what we want to do is we want to integrate u minus 2 log u du. I'll come back to the half in a minute, but I want to integrate this. Now this is a parts question. So my parts formula, I've put it up here, is the integral of u dv dx is equal to uv minus the integral of v du dx. Now I've got a bit of a problem here because my x term is actually u. So what I'm going to do is this becomes a u1 dv du equals u1v minus the integral of v du d1, sorry, that's u1 du du. So I'm going to let u1 equal log u and dv du equal u minus 2. So from here du1 du becomes 1 over u, and if I integrate this, v becomes a half u squared minus 2u. So if everything then goes into my formula, what I end up with is u1 times v, so that's log u times a half u squared minus 2u, minus the integral of v times du dx, so that's that times that, so 1 over u multiplied by a half u squared minus 2u. So we're looking at log u into a half u squared minus 2u minus the integral of, now a half u times u squared is going to be a half u, and 1 over u times 2u is just minus 2. So this is log u into a half u squared minus 2u, and then if I integrate this, if I integrate a half u, I get a quarter of u squared, and if I integrate minus 2, I get minus 2u. But because it's a minus minus here, this becomes a plus 2u, and then I'm integrating between the values of 2 and 4. So if I put in the 4 first of all, I get log 4 multiplied by, 8 minus 8. Take away, put 4 into here, and I get 4 plus 8. And then take away, what happens, what you get when you put in 2. So if you put 2 in here, you get log 2 into 2 minus 4, take away 1 plus 4. And if we sort this out, what we end up with is this is nothing. We've got minus 4 plus 8, so that's 4. Over here we've got a minus 3. So plus 4 minus 3 gives us a 1. And then we've got a log term here. We've got minus log 2 times minus 2. So what we end up with is 2 log 2 plus 1. But don't forget we had this half here that we didn't use when we were integrating. So therefore my solution is going to be a half of 2 log 2 plus 1. Or if you prefer, log 2 plus a half.